doing here is we're going to be doing some network troubleshooting with ping and traceroute, particularly testing two-way reachability. Two-way reachability is essential because we need to be able to test connectivity, right? We need to be able to ideally reach this host right here, this host right here, and in order for that to happen, we need two-way reachability between all of these hosts, right? Meaning, if this host wants to ping this host has to have access to a route to this host. And if we want to contact this host, we need to have access to a route to this host. But also the reverse is true. In order for that ping to work, this host and this host needs to have routes, respectively, to communicate to this host right here. And all of that action happens within the routers, right? So let's just go through the steps of the lab, right? So we have a scenario where a user, PC1, says that they can't reach PC3 and PC1. I made it nice and neat. It's a nice, neat scenario, something that we may or may not encounter in the real world. But the first thing that we might think is that since PC1 is the common denominator, that there might be something going on with their system. So the first thing we could do is we can ping our default gateway. Also, I'm not even gonna get into all that right now, but you know what? I might just jump ahead. How we're gonna be testing these paths is essentially slicing them up into small segments, and we're gonna test the segments, right? So I'm gonna get more in depth after we define what ping is and what traceroute is, because this is something that I'm still a little bit weak on. Well, I'm more weak on traceroute, not really I don't really have the expertise on how exactly traceroute works. So we're gonna study that for a little bit. So first, what is ping? Ping stands for Packet Internet Groper, and it's used to test connectivity between nodes via ICMP echo requests and ICMP echo replies. So an ICMP echo request is, well, ICMP stands for Internet Control Message Protocol, and an ICMP echo request is the request or the message that's sent out by the pinging host, meaning the host that is sending the ping out, that's initiating the ping communication, if you will, right? So PC1, say PC1 wants to ping PC2. It sends out the ICMP echo request all the way across this link to this host, and then it replies back with an ICMP echo reply. That's essentially how it works. Switches are capable of pinging when we set up IPv4 on them. Routers are capable of pinging. And essentially what we do is we ping nodes. This right here, this G0, what is this? G0, this Gigabit Ethernet 01 is a node. It has its own IP address, and we can ping it from right here, right? And also this interface right here as well, trying to pull it up, G00 on this side is also a node. It could be pinged from this PC right here or this PC right here, right? So pinging doesn't necessarily happen between, it's not necessarily just the device per se, it's the nodes, right? It can be anything with an IP address that has the ping capability attached to it, right? So what we have here now is a scenario where we want to ping the different host nodes to test connectivity, and that's what ping essentially is used for. Step 2 says, what is traceroute? So traceroute essentially tests connectivity of routers along a path of routers towards a destination. So we can do a trace route from this PC right here, and let's say it had internet connectivity. We could do a trace route from here out to maybe the Google servers, and then we can sort of trace the path along which the packet is traversing, and we can kind of get an idea as to the functional or the functionality functions of the routers, if they're functioning, or basically, let's put it this way, we can get an idea of the status of the routers along the path to Google server if we're tracing a path to Google server, right? So ping and traceroute, they essentially do two different things, but they're similar in the sense that we can test connectivity, we can check the status of certain machines or certain routers, and that's essentially what it is. Now in Cisco CCNA, we learn that ping can be, it can get a little bit, you can get a little bit more detailed with the way that you use ping, and you can do extended pings where when you're sending a ping, you can specify the source of that ping. And by doing that, you can test the reachability of the host that you're pinging back to the host that you pinged from, right? So that's essentially how we can kind of test two-way reachability when we don't have access to a specific node, right? So we went through what traceroute is, we went through what ping is, right? So I guess we can kind of start getting more into the scenario of how we would use ping, how we would use extended ping, and so on and so forth. So a user, right, PC1 says that they can't reach PC3 or PC2, right? So say for instance, maybe that user went home for the day and we don't have access to their computer. What we could do is we could simply log into router 1 and we can start making some assumptions or start deploying some tests based off of the very vague complaint that the user made, right? So let's say we log into R1 and then we test the pings to PC2 and PC3, right? Let's do that right now through the Cisco router. Right, we can do ping 192.168.2.5, right? And that's the IP address of this host right here. I should have probably labeled it. I'm really bad at labeling, so maybe I should label that. Let me put some labels down real quick. This is gonna be .5. This is gonna be .5. This is also .5. So I'll set them up, right? So we see right here that the success rate for the ping was 0 out of 5. So that was 100% loss. So the router can't reach this host, and we know that this PC can't reach the host, but let's see if we can ping the PC, right? And essentially, let's go back to what I was about to get into before. What we do when we have a scenario such as the one on top of this lab is that, okay, the user says that they cannot reach PC3 and PC2. What do we do with that information? So we can split up these paths to narrow it down to from PC1 to PC2, and then from PC1 to PC3. But then we can segment that path even further by saying, okay, let's test different segments, right? So what we did just now is we test the segment going to PC2, and then now we're gonna test the segment going to PC1 from router 1, right? We have a node right here and a node right here, which allows for us to test these paths from different directions, and we know that, you know, there's something going on over here because we can't reach this host right here. But just to be safe, let's test our connectivity to PC1. Let's test this local segment right here, right? And see if there's any issues right there, right? So hopefully there isn't, because I think I did this correctly. We're gonna do ping 192.168.1.5. My hands are cold. Feel that fall air coming in. So, or autumn for people that's watching that's from another country. In America, I believe we call it fall. But yeah, anyway. So we see that it has a 80% success rate, and that's because this was simply an ARP message from the router, right? So let's do it again. 100%, right? The ARP table is satisfied. It doesn't need to send out another ARP, and we have 100%. That means that everything is all good right here, right? But remember, we tried to test the segment from router 1 to PC2, and we got no dice, right? Now we can test this segment right here. Let's test the segment between R1 and R2 with a ping, that is. So we can do ping 172.16.1.2. And that's the IP address, that's the IP address of this node right here. And it's good. So we know that this segment is fine here. This segment is fine right here. But there's something going on right here. And let's use another tool, TRACEROUTE, real quick. So we can do TRACEROUTE 192.168.2.5, and let's see. Remember, this is the router R2, and what's happening here with this TRACEROUTE is it's sending out messages, but they're not getting any reply, right? So this TRACEROUTE has to go from here to here, right? It's going over hops, but there's something going on where it's not getting a reply, right? So we have to figure out what that is. We know that when we test the route with a ping, or this segment with the ping, we know that this works, and this might be questionable. So since we're the IT staff, we can log in to this router and let's see if there's anything wrong with this router right here. You can do ping to we know that this segment works right here, so we don't really need to test in that direction. Let's test in this direction from R2. Do ping 192.168.2.5, and it seems to be working, right? That seems to be working correctly. So what's going on here, right? Let's check again. Not getting it. We're not getting any luck, right? So we're able to, oddly enough, we're able to ping from here to here, but we're not able to ping from here to here. So now that clues me in on something. I mean, I already know the answer, but when I was studying for this, and I was doing certain labs without knowing the answers already, it clued me in, right? I said, why is it that this router can ping this host and get a reply, but this router can't? The only thing that I could think of is that this host is in a separate subnet than this router right here. And we all know, right, from our early CCNA studies, that in order for a host to communicate with another host or another node that's in a separate subnet, it has to send the packet to its default gateway. So that's cluing me in. Maybe there's something wrong with the default gateway settings. So let's check and see. The default gateway is stated to be 192.168.3.1, but that's not in the same subnet as this right here. That's over here. So let's change the default gateway to the correct default gateway, because we're seeing these are in separate subnets. So when it wants to communicate with a host on another subnet, it's not going to be able to do so because it's referencing the wrong default gateway. It needs to reference the default gateway, its own default gateway that's in its subnet, right? So let's change that to 2.1. Maybe that was a typo, right? Maybe one of our engineers put a typo in, and that's what was causing the issue. So now let's test the ping again. Wow, it works now. So we solved that issue. So let's just review the process that we took to solve that issue. When we're testing this ping, when we're doing when we're testing this segment, excuse me, we can just chop it up, right? We can't get access to this PC over here because the user went home. We don't have their credentials. So the next best thing to do is to just start pinging along different segments of this whole complete path right here. So we pinged from R1 to PC2, couldn't get a reply. So we said, all right, let's test this segment right here. We pinged, we got a reply. Then we also earlier tested this segment right here. That was fine, right? Then we tried to ping from R2 to the PC2, and we got a reply. So then that started cluing me in. If I can't ping from here or here, but we can ping from here, maybe it's a default gateway. So we checked the default gateway and we found it, right? So that's basically the thought process, and maybe your thought process is way different than mine. But that's how I would investigate or begin investigating why we can't get reachability from PC1 to PC2. But we have another issue. We can't get access to PC3 for some reason. And yes, PC1 is conveniently the common denominator, which would lead us first to think, if we didn't, already solve this issue and know that this is fine. Again, we want to test connectivity between R1 and PC1, which we don't really need to do because we know that the settings between here and here work. As a matter of fact, we actually don't. So what we're going to do is we're going to do an extended ping, because remember what I said, R1 and PC1, or R2 and PC2, they were able to communicate with each other despite the fact that this PC's default gateway settings were flawed, right? So that meant that obviously they were communicating on layer 2, right? And it doesn't need to, they're in the same subnet, so it doesn't need to communicate through a default gateway. So it's able to just send the packet or the frame straight to the PC2 without a problem. But if we were to rewind back, how would we have known that everything was all good if we tested between these two nodes right here, if we're pinging from this node right here, which is in the same subnet, which would allow connectivity without having to go through a default gateway, right? So what we can do is we can utilize an extended ping. And how we utilize an extended ping in Cisco and Cisco router, for that matter, you just do ping and then we can hit enter, and it's going to ask us a series of questions. It's going to ask us what protocol we're using. We're going to use IPv4, which is IP. The target address is going to be 192.168.1.5. Repeat count, I believe that's how many times it's going to ping it, right? Datagram size, that's the size of the packet, I believe. Correct me if I'm wrong. Haven't really gotten into the finer details. Timeout in 2 seconds. Obviously, that's the timeout counter. Extended commands. Now, that's where we want to, dabble in a little bit. So we hit yes. Source address or interface. We're going to use this outside interface here because we're gonna test the default gateway of PC1 to make sure that it's in working order. I mean, we already know that it is, but this is something that we could have done because PC1 was the common denominator with unreachability between PC1 and PC3 and PC1 and PC2, right? So the source interface is going to be the IP address of this outside interface right here, 172.16.1.1, I believe it is. Yeah, should be .2. So let's hope it's the right one. Type of service, I'm just gonna hit enter, hit enter, hit enter, hit enter, hit enter, hit enter, and then it works. So we know that the default gateway is working properly. Now let's go back to testing reachability between PC1 and PC3. So we're gonna do ping 192.168.3.5, right? We're gonna hit that up again and see what happens. Success. Why did it get success? It's supposed to be, I don't know. It's getting success. Oh, it's from R1. Wait, let's do PC1. I think that's initially what I wanted to test. Let's do ping 192.168. But it's getting reachability. I guess I screwed up the lab because that's not what I wanted to do. No, it makes sense. It makes sense. I tailored this lab in a specific way to get specific outcomes, which is really not realistic, but just roll with me here. Just bear with me. So we know that we essentially just did a test, right? And we was able to rule some things out. So we know that PC3 is reachable from R1, and we know that PC1 is reachable from R1. So even though that was an unscripted, we went off script real quick, we can kind of start making some assumptions that router 1 has some way to reach PC3, but PC1 and PC3, they're having issues communicating with one another. Like, what could that be? We can start testing the reachability between PC3 and this subnet right here. And the way we're going to do that is, again, using an extended ping. So we're going to go back to router 1. We saw that we was able to ping from here, right? And it works fine, just fine. And the reason why that is because it's pinging from this outside interface. So let's try, because we're starting to clue in. Maybe there's a route, or there's routes, sufficient routes for R1 to reach PC3 from this outside interface, and PC3 to reach R1 on this outside interface. But for some reason, we can't reach anything, or we can't reach PC3 from this subnet right here. So we can start to say, okay, we have a hypothesis. Maybe PC3 doesn't have a route back to this 192.168.1.0/24 network. So let's test that out. So we're gonna do ping, right? And then we're gonna hit enter. IP, obviously, or we could just hit enter. The target IP address is 192.168.3.5. Repeat count 5. Datagram size 100. 2. And yes, right? Source address or interface. We're gonna use this inside interface right here, which is gonna be 192.168.1.1. and we're gonna hit 0, and we're gonna hit enter for the rest of them. Let's see what happens. Packet was sent with the source address of 192.168.1.1, which belongs to this subnet right here. Success rate is 0 out of 5, right? It's not able to reach it. So now we have, I mean, we pretty much have all we need, but let's use TRACEROUTE. And let's TRACEROUTE from the outside interface by just doing the default TRACEROUTE. Do TRACEROUTE 192.168.3.5. Boom, it works, right? So it hopped from here to here, and it was able to reach PC3. Fine. Now let's do an extended TRACEROUTE. Do TRACEROUTE. Let's hit enter. IP, of course. Target IP address 192.168.3.5. And then source address. This is much simpler. We're gonna test this inside network off of router 1's G01 interface. I believe it's G01. I don't know. It doesn't matter. Let's put the IP address. 1.1 numeric display. Let's just keep going. Probe count 3. So the probe count, that's these, all right? It sends out packets. And by the way, Cisco routers use UDP for TRACEROUTE. That's something that you should know. And I think ping too. It uses UDP for both of those. So just you could double check me on that. I'm just calling it off the top of my head. Tracing route. Some jams right here. Switch up the playlist a little bit. We're not getting anywhere. Because, again, now we know that there's an issue with this PC not being able to have a way to get back to this subnet. So we're gonna investigate this router right here. All right, so R1, let's do show IP route. Let's check the routing table. We know that we can get to this subnet, and we use static routes, by the way. Ugh, yuck. They have their place, but yeah, we don't really want to be configuring static routes all over the network. But we have a way to this network right here, right? And we have a way to the other network over here. Nice, cool. That looks fine. This looks fine to me too. These are directly connected routes, and we expect to have 2 sets of them, all right, because they're directly connected. Now, let's go on and check R3, because this is the suspect right now. I like to do all of my show commands from global configuration mode, because I could just use the do keyword, and it allows me to see the show output, and it also allows me to pivot into configuration. That's why I like doing this, right? Do show IP route. All right, let's look at this routing table. So we see that it's directly connected to its own route right here. And we see that it has a way to this network over here, right? And we see that it doesn't have a way to this network over here. So let's just test, right? Let's test to see if it actually can reach this host over here. And then we'll definitely we know what the problem is, but you know, let's just be extra real quick. I don't think I configured the route. I think I left out a route. So yeah, we're doing some extra troubleshooting here. This is again off script. So we know that this router has a way to reach this network over here, right behind this command prompt. But let's see if this router has a way to it. See, this is all testing two-way reachability. Do show IP route. No, this router doesn't have a route back here. So when I was setting this lab up, I forgot to put that command in. So IP route 192. Let me save this real quick because this thing crashes on me sometimes. 168.3.0 255.255.255.0 and we're gonna go ahead and say 172.16.1.2 is the next hop. Oops, it's 1.1. Oops, 1.1. And now let's test the ping. See, it's working now. Because now, although this computer, this host, has a route here, it didn't, this router, this computer didn't have a route back because it was missing that route that we just put into R2. Now we have two-way reachability between PC3 and PC2, right? So that's more two-way reachability practice that we did just now. But again, we still can't ping PC3, right? All we have to do is go into this table right here and put a route for this network right here. IP route 192.168.1.0 255.255.255.0. Then the next hop is 172.16.2. I forgot which one it is. Let me see. It's going to be 2.1. 2.1. So now we should have no issues. Now we have a reply. So we just fixed everything, right? Now PC1 can reach PC2 and PC1 can reach PC3. That's all there is to it with ping. With ping, and let me pull up a website talking about ping real quick because I think this is cool. So this website right here, techtarget.com. What is ping? A ping, packet internet or inter-network groper, is a basic internet program that allows a user to test and verify if a particular destination IP address exists and can accept requests in computer network administration. The acronym was contrived to match a submariner's term or submariner's term for the sound of a returned sonar pulse. So if you know anything about sonar, right? Sonar image, because I just had this image in my head, right? This is a sonar, right? And it's basically just scanning for anything that is, I guess, making a vibration, right? And sonar is done using sound, right? So that's where ping comes from. But in your network, you can think of ping sort of the same way. You're sending out an echo, right? But you're sending it obviously towards a target. And you're kind of like feeling around on the network. That's how I kind of look at it. You know, you testing connectivity here, testing connectivity there, you're testing connectivity all throughout the network to break down or to narrow down where you think the problem is, and then you find the problem and you solve it. This is very important, by the way. This is why I'm constantly going over this stuff, to keep my skills fresh and to help those of you who want to also keep their skills up to date as well. Because once you get the CCNA, you still have to practice this stuff day in and day out to keep your skills fresh. I'm noticing that even within myself too. Like if I don't practice this stuff frequently enough, I get rusty. So that's it for network troubleshooting with ping and traceroute.